Well, now I'm going to take the exercises from the notes. This one is the first one, and it says the integral of 5 minus 6x times the x. As you can see, the x is multiplying both terms. So the first rule I'm going to use is the addition or subtraction of integrals. So I'm going to do the integral of 5 times the x, because again the x is multiplying both terms, minus the integral of 6x times the x. So I'm doing the product of the differential and the rule of the subtraction. Then I have a constant here and a constant here. So I'm going to do 5 times 1 times the x minus 6 times the integral of x times the x. And now I'm going to use the rules we have studied. I was forgetting to tell you that you have to write those rules on an index card so you can keep it with you whenever you're working. So you can look at them, you can practice them, and at the end you're going to learn them and memorize them. So if you look at the rules, the integral of 1 times the x equals x. So I'm going to have 5x, because the integral of 1 dx equals x plus the constant, minus 6 times the integral of x, which is x to the 1 plus 1 over 1 plus 1 times the constant. So we have 5x minus 6x squared over 2 plus just one constant, because we have said that we don't need that many constants because we don't even know the value. So we're going to add only one. And finally, we want to simplify to 5x minus 3x squared plus the constant. So this is the function whose derivative equals 5 minus 6x. So we can check it. If you find the derivative of 5x, that will be 5. Oh, wait, let me use the arrow that helps to show you what I mean. So here we are. We have the derivative of 5x equals 5. And the derivative of negative 3x squared will be negative 3 times 2. That is negative 6x. Questions? Well, if you have questions, I'll be around to help you. So to obtain the integral of radicals, we're going to write them as rational exponents, just like we did for derivatives. So now that we have the integral of x to the 2/3 times dx, all we have to do is to add 1 to the exponent, 2/3 plus 1, over 2/3 plus 1 plus the constant. So we're going to have x to the 5/3 over 5/3 plus the constant. And then we're going to simplify the one that is not written here over the 5/3. So let me show you that we want to divide 1 over 5 over 3 in order to find the coefficient of x. So I'm going to do this right here because I want to make sure that is clear for everybody. So let me write it. We're going to do 1 over 1 over 5/3. So we have to multiply 1 times 3, which is 3, over 1 plus 5, which is 5. So finally, we have 3/5 times x to the 5/3 plus the constant. So if you want to know if we did right, all you have to do is to obtain the derivative of this integral. And finally, we're going to rewrite the rational exponents as radicals. So it is 3/5 of the cubic root of x to the 5 plus the constant. So the rule is to rewrite rational exponents as radicals and to rewrite negative exponents as positive exponents. This is exercise number 7 from the notes. As I told you, and I want to recall you, and I want to point out and make sure you understand, whenever you have a product, you have to find the product before you obtain the integral. There is no rule for the integral of products, so keep that in mind, please. It's a very common mistake to do the integral of x plus 1 times the integral of x plus 2. So avoid that mistake. Remember, Houston, the ones who were for you for last semester, Houston, we have a problem. So whenever you find a product here, a multiplication, do not do the integral of this times the integral of this. You have to obtain the product first. So I know that I say this too many times, but trust me, that's a pretty common mistake. So let's start by finding the product of x plus 1 times x plus 2. So as you know, we have to do square of the common term, addition of the non-common term, which is 3 times the common term, because this is a notable product, if you remember, and then plus the product of the independent terms. That will be 2 times dx. What we have here now is a very simple integral because we have an addition. We have here plus and plus times dx. So this is, after we do the product, this becomes pretty easy. So let's work with it. We're going to obtain the integral of x squared times dx, because don't forget that we are multiplying the x by x squared, and then the x times the x, and then the x times 2. So that's why for each term, for each integral, we have the integral of 3x times the x plus the integral of 2 times the x. Now, what do we have here? We have pretty simple integral because we have only x squared. We have a constant here, so we're going to do the constant times the integral of the function. We have a constant here, so we're going to do the constant times the integral of the function. So before I do this integral, because I want to do the integration of the three terms at the same time, I'm going to use the constant rule first for these two terms. So what I'm going to do is to rewrite this one, because I'm not doing anything with this term, with this integral yet. But with here, I'm doing 3 times the integral of x times dx plus 2 times the integral of 1 times dx. So what is the rule that I'm going to use for this very first integral? Well, the rule for x to the n, the integral of x to the n, which equals the integral of x to the n plus 1, which is 3, over n plus 1, which is 3, plus 3 times the integral of x. And for the integral of x, we're going to use exactly the same rule that we used for this one. We have to add 1 to the exponent and to divide by that addition of the exponent. So what I'm going to do here is x squared over 2. And then plus 2 times the integral of 1 times the x. But the integral of 1 times the x equals x. So this integral becomes only 2x plus the constant. Do we have to simplify something? No, we have positive exponents. We don't have rational exponents. So all we can do is to rewrite this as x cubed over 3 plus 3x squared over 2 plus 2x plus c. So if we try the derivative of this function really quick, we would have to do 3x squared over 3 because 1/3 is a constant. So that would be 3x squared over 3. That would be x squared here. And then if we do 3 times x squared over 2, its derivative would be 3 times 2x to the 1 over 2. And we simplify the 2 and we obtain 3x, which is this 3x. And then, and finally, if we find the derivative of 2x, its derivative equals 2, which is here. And then we have this expression that if you factorize, you obtain this product. This is exercise number 8 from the notes. We have a quotient here. That's why I want to solve this in this video, to show you that we don't have rules for the integral of quotients. So we want to do the quotient first, and then we're going to check some other techniques to find the derivative of these kind of functions and the previous one. So the integral of t squared plus 2 over t squared equals the integral of t squared over t squared plus 2 over t squared. And we are able to do this because we have just one term in the denominator. Oh, I'm sorry, I forget. I'm making a mistake with this differential because now the independent variable is not x, it's t. So we're going to simplify this, and we have the integral of t squared over t squared equals 1 times plus 2 times t to the negative 2. As we did with differentials, we want to write exponents in the denominator as negative exponents to find the integral times differential of t. So now we have the integral of 1 times differential of t plus the integral of 2 times t to the negative 2 times differential of t. So we're going to use the same rules even though we have a different independent variable. The rules work exactly the same. So the integral of 1 times differential of t equals t plus the constant 2 times the integral of t to the negative 2. And that we have to add 1 to the negative exponent. So we're going to have negative 1 over negative 1 plus the constant. And we're going to rewrite negative exponents. So we have t plus, minus, because we have this division of a positive number over, we have this division of a positive number over a negative number, so it becomes a negative term. So we have negative 2 over t plus the constant. So that's it for this video. These are the basic rules of integration. We're going to check after this the substitution by changing the variable, and then some other techniques. So study a little bit before you start your set number 6 from the second pathway. Thank you.